Hello, everyone. Thank you for tuning in to The Cardinal Journey, a story about bringing Jamf to Stanford University. I'm Jeff Barco. I lead a team called Endpoint Engineering and Development, or EED. We're a part of University IT, and with me, we have Chad Morales and Jonathan Morton, representing Stanford Healthcare and School of Medicine, as well as Forrester Terry, our software developer lead in EED. And last, but far from least, Matthew Phillips is joining us from Jamf, Stanford's implementation engineer, who has been working with Stanford since day one. Everyone here and so many more have been critical to the success of Jamf at Stanford. In just 1 year, we have made significant progress from deploying to 14,000 macOS devices to developing a custom enrollment application, building integrations between Jamf and our compliance systems here at Stanford, and as we speak, moving forward to further deploy to 35,000 macOS devices and 25,000 iOS devices. We've come far, but clearly we have farther to go. But before we dive into that, let's talk about the Stanford environment. Stanford is unique among its peer institutions in having 7 schools co-located on one contiguous campus. Each of these schools is further unique in its breadth and depth, resulting in different needs that are realized even through IT. Many have their own IT department who are responsible for the management of their devices, yet rely on the central IT organization, University IT, to establish systems, processes, requirements, and much of what dictates the computing environment. Though there very much is a balance between distributed and central IT. What might be considered standard in an enterprise organization can be challenging to implement in the university environment. University IT must partner with distributed groups as well as students, faculty, and staff to ensure there are options in what's imposed. Or, at the very least, intentions are well communicated. So, as we endeavor to bring entirely new management systems to the campus, it's important to look back at where we came from. For the past 17 years, and likely a few more years to go, we've been relying on a management system called BigFix, installed on over 52,000 macOS endpoints. It has been essential to preventing security nightmares, as you can see from the article still up from 2005. But with macOS High Sierra, we started developing challenges. We couldn't install and configure our anti-malware solution at scale anymore. We couldn't automate the rolling of local admin passwords. And our ability to manage macOS devices at Stanford started to fade. While leadership discussed replacement options, units started implementing Jamf for their purposes. A popular use case was provisioning workflows, where once again technicians could automate the installation of packages. Another use case was in kiosk or lab management, where administrators needed to ensure their fleet of devices met the specifications of their users for a consistent and reliable experience. It's true, Jamf has been at Stanford for a few years now, but it wasn't until just over a year ago that work began to implement it centrally. And before we get into that, I'd like to turn it over to Matt Phillips for a few words.
Thanks, Jeff. So, when Stanford approached us with their OAuth 2.0 mail needs and the iOS migration opportunity, we were excited and eager to show that it could all be done using Jamf, but we couldn't stop there. My team is committed to building seamless integrations that push the envelope of what's possible today with Apple device management. This Jamf migration had to be the best in class for the admins and the end users. We knew that Jamf engineers would need to work closely with Stanford from the beginning to configure a stable and secure Jamf Cloud environment, one that was already fully integrated into all the existing university services. During that planning and architecting phase, there were parallel efforts from another team at Jamf, Client Engineering. They were able to provide a dedicated resource whose ability and breadth of knowledge allowed him to simultaneously support healthcare, university IT, School of Medicine, and children's health. This is no small feat. And having that insight into the different wings of Stanford has allowed us to facilitate rapid, relevant support that helps eliminate redundant effort. Also, while driving innovation by sharing new developments across the entire organization. And speaking of different groups at Stanford driving innovation, the School of Medicine team is going to talk about their trailblazing efforts to get Mac management with Jamf ready for prime time at Stanford. Take it away, guys.
Hi, my name is Jonathan Morton, and I am a Jamf administrator in the Technology and Digital Solutions group at Stanford Medicine. Our story with Jamf begins around 2016. We had had BigFix for over a decade in the university as the chosen instrument for enterprise management. Other people were using Jamf. The few groups that did were mostly using it as a deployment solution. I know that in CRC, which is the university support group, they had a deployment solution called Ding that used Jamf as its back end, but didn't leave Jamf on the machine. And that's more or less where we landed. We started Med School's Jamf in Thanksgiving of 2016 with a kickstart for a local on-prem server and about 200 licenses. And we had been told in no uncertain terms that we were not allowed to leave Jamf on the machine because we have one enterprise management solution. We can't have two. It has to be taken off. And then in the meantime, events began to change. 1013 dropped, and that meant kernel extension approvals and user approved MDM. And then 1014 dropped, and that meant PPPC controls and having to allow specific permissions for the desktop or the camera or whatever else you have. And it became obvious that the writing was on the wall for every management solution that wasn't an MDM. We tried to communicate this up the chain, and we were told to do some due diligence and explore some other solutions and test some things out. We ended up losing about a year proving what everybody already knew, which is that Jamf is the industry standard. Jamf is, the segment leader. Jamf is the only reasonable thing to put on these machines. We finally got through to management and got approval to start proceeding with Jamf. And then out of almost nowhere, we found out that the technology units of the School of Medicine were going to be merged into the technology arm of Stanford Healthcare and Stanford Hospital, which left us with an interesting conundrum. We now had three possible options for our Jamf solution. Door number one was we take our own on-prem Jamf server, North Star, Hat Tip, Minnesota, which was 4 years old, and the hardware itself was out of warranty. We only had 200 licenses, and it was fairly obvious that that wasn't going to scale without rebuilding it from the ground up. Door number two was to go to hospital and attach ourselves to their Jamf. And they do have a best of breed implementation. It's an excellent service for managing iOS and tvOS, and they do it as well as anybody in the country. But they don't manage a lot of Macs with it. And we were not really in a position to come in and say, hi, you guys manage 300 Macs. How would you like to expand that to 10,000 in the next 2 months? That's not the best way to make a good impression. So that left us with door number three, which was university. These are still university computers. They're on a university network. They have university users. Obviously, university Jamf is the right decision. The only problem is university Jamf was not in production yet. They were still testing. And so we looked at the situation in front of us, which was fairly complicated. We didn't have anti-malware software anymore. The powers that be had ended our license for ESET, which had only been put in as a continuation of SCEP for the Mac. And with ESET gone, we didn't have anything to prevent machines from catching malware. The official solution was CrowdStrike. We're going to roll out CrowdStrike. The answer is CrowdStrike. I literally have an email that says the answer is CrowdStrike. The only problem is deploying CrowdStrike means you're going to have to approve extensions. You're going to have to set permissions. In short, you need an MDM if you're going to roll out CrowdStrike. So what we did was we went to university and said, look, we are willing to be the pathfinder for this deployment if you'll let us use your Jamf to roll out Jamf and CrowdStrike on all of our Macs with high-risk data as quickly as we can. And they were very agreeable to this. So then we looked at the situation in front of us. It was late 2020. So global pandemic, half of the med school is working remotely. Most of IT is working remotely. We're not going to be able to do this with human wave attacks. We can't go door to door and say, hey, we're here to install the anti-malware on your machine. And we certainly can't show up and say, hi, we're here to install a new management solution on your machine, because as we know, our faculty are fairly persnickety about what controls their machine. On top of that, we had another problem, and that is that in late 2020, there was an ongoing phishing attack on multiple healthcare institutions all over the country. And we've spent years and years and years telling our users, do not click on random things that pop up out of nowhere and ask you to install something. And now we were presented with the problem of having to tell our users to please click on this one random thing that pops up out of nowhere asking you to install something. So what we needed to do was come up with a tool that could be deployed with our existing management system that would install Jamf, that would pave the way to install CrowdStrike through Jamf, that could be very simply executed by the user, pre-stage as much as possible, allow them to only click a couple of things, never enter any network credentials of any kind, and have directions so simple that they could be rendered as an animated GIF. That was a pretty tall order. So what did we do? I am so glad you asked, because roll up, ladies and gentlemen, and feast your eyes on the wonder of the age, the magical elixir of deployment, and the answer to all your prayers, Dr. Chad Morales' internationally known patent organic School of Medicine enrollment tool, as presented by the man himself, the one, the only, bona fide Jamf certified, Chad Morales, Senior Jamf Administrator, Stanford Medicine.
Thank you, Jonathan. So there we were in late 2020 in the midst of an unprecedented cybersecurity threat targeting healthcare systems. And we needed to deploy a new endpoint software security suite as soon as possible. The tool that we had at the time wasn't an MDM solution, so we'd be able to install the suite, but it would require manual intervention by our clients in order to configure it properly after the fact. We were, however, in the beginning stages of planning our Jamf deployment, so we had options. We could use our current tool and hopefully provide documentation sufficient enough that our clients would be able to enable full disk access, approve a kernel extension or system extension, and do that reliably enough for successful rollout. Or we can drastically move up our Jamf deployment. And that seemed like the appropriate solution to us. So we're thinking, great, let's go ahead and add the Jamf package to our management tool, deploy that out. We'll get all of our devices enrolled in a few days, and we'll be off to the races. Of course, it's not that simple anymore. After macOS 10.13, we need to install Jamf with a configuration profile. So we worked out how we want to do that and make it as simple as possible for our end users. What we landed on was building a very simple Swift app that will facilitate the enrollment of these devices. The app will detect what state the MDM is in for the computer. If the computer is fully user approved, we'll indicate as such, say thank you, and we'll quit. If there's a profile waiting to be approved, we're just going to go ahead and remove the profile and start the process over so there's no hiccups. And once we've gotten past that, the app itself just shows an animated GIF of what that process is going to be, and that there's going to be clicks involved to move this process along, and a start button to do that. Once they've clicked that button, what we're going to do is, using a hidden web view controller, we're going to inject some JavaScript, and using enrollment only credentials, we're going to navigate through the enrollment process in a hidden fashion. We're going to download a configuration profile for that device. We're going to stage that in the profiles system preference pane, and then present that to the user in order for them to go ahead and click install and move the computer through the deployment process. Once that's completed, we've got a computer that is completely enrolled in Jamf, user approved. We're able to send down those configuration profiles with PPPC and approve those extensions appropriately. And that's what we came up with in a few short days for our Jamf deployment of nearly 10,000 devices. You'll see on this next slide the progression. We started slow with a few hundred devices a day and very quickly ramped up. There's a plateau here of 3 weeks. That was a winter closure for the university, so not many devices are being used. Over the course of those 7 weeks, we were able to get to nearly 10,000 devices, and that really set the stage for the university to take what we learned in our experience and our tools and build upon those for the greater university's deployment. So with that, I'll hand it back.
With the efforts over in the School of Medicine in Stanford University to deploy to thousands of devices, we knew there would be challenges to scale up for the rest of the university, while delivering the kind of user experience we expect. So, earlier this year, we endeavored to create an application that would do just that. That could improve upon the out-of-box enrollment process with Jamf and be deployed with our existing endpoint management solution, BigFix.
Hi, my name is Forrester Terry, and I am a software developer lead within Stanford University IT. I'm going to talk briefly about how our custom enrollment application works. Our goal was to make it easy to deploy Jamf using our existing patching solution, BigFix. The big challenges we recognized for this task were, how do we make sure end users follow the enrollment process from beginning to end? And then how do we make this process as easy as possible for our IT groups to adopt and use? Our metrics for success included measuring changes in overall adoption rate, the user's engagement with the app, specifically whether they looked at the information we outlined regarding what Jamf can or cannot do, and then the overall adoption rate via this enrollment app. I'm going to show a video that briefly demonstrates the workflow. The user would download the app, they would run it, and upon running the app, they'll be presented with a welcome screen. The welcome screen then takes them to a screen where they can see what Jamf can or cannot do to their computer. From there, they're taken to an SSO page where they're actually going through the Jamf user-initiated enrollment. This is the normal enrollment URL that you would use for that method, just contained in the web view. So they'll sign in. This particular user happens to be an enroller, so they're going to get the option to assign the computer to a user as well as assign it to a site. And then from there, the user is going to be directed to install the configuration profile. What will happen at this step is the user will see a prompt that the profile installation was attempted. They'll need to approve it and whatnot. And what our app will do is check to make sure that if they have not accepted the profile, that they're redirected back to the system configuration pane to accept the profile. And then they proceed. To build the app that you just saw, we use some frameworks that our dev team is familiar with already, specifically Vue.js and Electron.js by way of a framework called Quasar. We chose this stack because Vue.js is very easy to work with, and a lot of our developers already know JavaScript and Node. This approach also allows us to build cross-platform components for both mobile and web if need be. So far, through our initial rollout of the app, we have had 2,722 runs of the app, leading to 1,972 successful enrollments. The app has been used in over 30 countries across our organization, and it took about 3 minutes and 31 seconds for the average user to get through the process. Overall, the experience has been very good, and we anticipate deploying the app out on a wider scale in the months to come.
So now you're caught up on what we've been doing so far. Let's talk about what we're working on in the next steps for Jamf at Stanford. Continuing the concept of facilitating enrollment as best as possible, we'll first cover what's happening with our iOS migration, moving from our current MDM solution to Jamf for nearly 25,000 devices, utilizing a custom app built by the Jamf implementation engineering team. Then, we'll discuss Sitemapper, a tool to automate Jamf site device membership. And finally, Cardinal Connector, a link between Jamf and Stanford's compliance system. Moving from one MDM to another on iOS can require a lot of manual steps, and it can be taxing on our support staff. Our device environment is mixed. The majority have gone through user-initiated enrollment, but we still have many supervised devices that went through automated device enrollment. Furthermore, we have a separate initiative to move to modern authentication for our mail profiles. And we learned Jamf could improve the user experience by migrating their iOS mail client to modern auth without affecting their other desktop mail clients. So when designing a migration workflow, it was important to take the mail migration piece into consideration. We partnered with the Jamf implementation engineering team, and they offered an improved workflow by way of a custom application called Swipe. This app will save the user the effort of unenrolling their device, using an API to talk to our current MDM solution, and guide them through the process of enrolling into Jamf. The goal here is to create the best experience possible for our users.
Swipe for iOS was born out of necessity. How do you allow your end users to choose the time that's best for them to migrate from another MDM? Often we talk about the carrot that gets them to enroll, like access to their mail or VPN. You could give your users a guide of the enrollment process, but this is inelegant, even impossible if the MDM is not removable on the device. IT admins would have to get involved, and with a remote user base, this complicates things even further. You could make it an HR violation, tell them, migrate your devices or else. These aren't great solutions. We needed an easy and secure way for the end users to remove MDM and then enroll their device into Jamf while minimizing productivity downtime. Swipe was originally written as a user-driven automagic tool for remotely wiping the devices from one MDM and leveraging Apple's automated device enrollment into Jamf. But it has evolved into so much more than that. We don't need to wipe the device. Today, we offer a custom branded experience with the ability to enterprise wipe or unenroll the device from the current MDM and then guide the user to Jamf with the absolute least amount of steps as possible, even eliminating enrollment authentication if desired, while still complying with Apple's MDM spec and security standards. In working with Stanford, we have been able to expand our iOS migration apps feature set that will directly benefit everyone interested in bringing their iOS fleet into Jamf at scale.
Next, I'd like to tell you about how we're trying to approach distributed management. Early on, we had to decide, should we have one Jamf instance for the whole university, or an instance for each school or group or unit? We opted for one Jamf production instance, leveraging the site functionality in Jamf for distributed IT groups. We wanted Jamf site membership to be automated, eliminating human error, where membership was dictated by attributes readily available in Stanford's directory. Enter this concept of site mapper. The idea is that a Jamf site administrator creates a site mapping, informing on what organizational buckets to associate with a site. When a user enrolls a device into Jamf, they're not given the option to select a site. SiteMapper assesses these newly enrolled devices and moves them into the proper site, if a mapping has been created.
SiteMapper is a tool aimed at automating Jamf site assignments for our distributed IT groups. But why the need for this solution? Well, Stanford has a variety of end users with different affiliations and device management needs, such as users bringing their own device, faculty buying devices with their research funds, and then departments buying devices for their staff, etc. Existing solutions do not cover all of our scenarios, so we built a way to evaluate any endpoint enrolling into our Jamf server and perform a lookup against Stanford data to determine what site the user belongs to. The slide is a bit more messy than it needs to be, but essentially we are using Jamf APIs and Jamf webhooks to coordinate this entire process. A Jamf webhook tells us when a computer has enrolled into the Jamf server, and if the computer has a user assigned to it, and the computer is not already in a site, we will look up some Stanford data about the user, such as affiliation. And using a database with defined site mappings, we see if the computer belongs to any particular site, and if so, we use the Jamf API to move the computer into that site. In the future, we are looking to incorporate mobile endpoints as well. Additionally, we have other Stanford tools and services which would tie in nicely with this process. Using the Jamf webhooks and API, we are able to build really robust workflows at scale.
Next up, we'll talk about Cardinal Connector, an integration between Jamf and our device compliance system we call My Devices. At Stanford, for your device to be compliant, it must meet certain requirements and constantly check in to our compliance system, continuously reporting on its compliance status. The front end of our compliance system can be seen here. This is a screenshot of My Devices. It allows a user to view all the devices associated with them. They can learn more about each device by clicking on it. And more importantly, they can determine which devices are out of compliance. From there, they can take actions to remediate their compliance status. So it was very important that we integrate Jamf into this system so that by having Jamf at Stanford, you could be compliant. A connection between Jamf and the system had to be developed if we were going to switch from BigFix as our management system, which determines compliance, to Jamf. Enter this idea of Cardinal Connector. And again, in partnering with our Jamf implementation engineering team, we discussed options to provide this solution.
The Cardinal Connector. It's things like this that are one of the more exciting parts of my role at Jamf. That is, taking on a new blue skies project, given only the requirements and the desired end result. We draft out all the possible ways to create a solution, often coming up with several drastically different POCs just to see which one sticks. Early builds of CardEC were basically a modified version of Java, the Jamf automated webhook assistant, but we added logging and a webhook receiver for third-party sources. We increased communication security and overhauled the UI. It looks really cool. And again, these advancements directly benefit everyone as they have been added to Java 3.0, which is available now on Jamf Marketplace. Today, the Stanford Cardinal Connector code sits on a Java 3 server between Jamf and the Stanford My Devices compliance database, while also incorporating other non-Jamf data sources into the feed for business groups like healthcare. The Cardinal Connector allows end users to check on their own device compliance in real time and send NDM commands like loss mode or wipe to their own device without risking exposing Jamf API credentials. And with a group like Stanford, new innovations are being added all the time.
I want to extend a very big thank you to our speakers today. Matthew Phillips from the Jamf team, Forster Terry from Endpoint Engineering and Development within University IT here at Stanford, Chad Morales from Stanford Healthcare and School of Medicine, and Jonathan Morton, also from Stanford Healthcare and School of Medicine. And I'd be remiss if I didn't extend a huge thank you to everyone else from the Stanford team to the Jamf team. A special thank you to Jimmy Vallis on the EED team who couldn't join us today. It's been really exciting to see how far Stanford has come with Jamf as a product and partner to our success. From deploying to over 14,000 macOS devices, developing a custom enrollment app for macOS, launching Sitemapper so those enrolled devices can go to the right site, and integrating Cardinal Connector so those devices are compliant at Stanford. Then lastly, partnering with Jamf to create an improved iOS MDM migration experience. We still have a tremendous amount of work still cut out for us, but are thrilled to once again have the ability to effectively manage devices at scale. Thank you.